Okay, let's unpack this. Welcome back to the deep dive. Today we are strapping into the electronic heart of modern aviation, specifically targeting the complex knowledge required for your airline transport pilot license theory exams. Our mission is crystal clear. A deep dive into the world of modern jet engine control systems, autothrottle, or AT, and the powerful, full-authority digital engine control, FADEC.
Yeah, these aren't just, simple autopilot features. They are essentially the electronic brains managing the most critical system on the aircraft, the thrust. And for the ATPL, just knowing the names, well, that's not nearly enough. We really need to solidify the mechanics, the different operational modes, and crucially, those failure and disengagement rules. They can be a bit counterintuitive sometimes.
Absolutely. Think of this session as maybe the ultimate shortcut to getting really solid on the systems the examiners just love to ask about. We're going to try and synthesize all the components, the inputs, the outputs, everything, into clear, testable concepts. The big picture we want you to leave with is this. Yeah, these systems automate thrust control brilliantly, but understanding their limits, their boundaries, that's what really separates a competent pilot from a truly great one.
Okay, let's start right at the source. The autothrottle system itself. Your source material defines the AT as a computer-controlled electromechanical system. Now, that term electromechanical, it's important. It confirms there are actual physical actuators, servos, that are responsible for moving the pilot's thrust levers. This system, it's often part of a larger thrust management system, or TMS, and it works closely with the autopilot and the flight management system, the FMS.
Right, so it's not working in isolation. It's part of a team.
Exactly, a team effort.
So, okay, we're talking about a system that manages thrust. But like you said, a jet engine doesn't have a simple gauge that reads out pounds of thrust, so the control has to be indirect, right? That seems like a really fundamental point for the exams. How does the AT actually measure or define the thrust it's aiming for?
Well, it has to rely on surrogate parameters, things it can measure that correlate very directly to the engine's power output. And there are three primary ones you absolutely must know for your examination.
Okay. Three key parameters. What's the first one?
The first and probably the most common you'll encounter on modern turbofans is fan speed, N1. This is simply measuring the rotational speed of that big fan at the front, the low-pressure compressor fan. It's reliable, it's visible to the pilot, and it directly relates to the mass of air being moved. The AT calculates the N1 it needs based on, the phase of flight, temperature, things like that, and then it commands the throttles to achieve that specific N1 speed.
Makes sense. N1. What's the second parameter?
The second one, which you'll still find on many, particularly older or larger high-bypass turbofans, is engine pressure ratio, EPR. EPR measures the ratio.
Yeah.
It's the total pressure coming out of the jet nozzle compared to the total pressure going into the engine inlet. This gives a very accurate sense of the actual work the engine is doing, but it does require slightly more complex sensors and probes. When the AT is in EPR mode, it's constantly adjusting the throttles to hit that target pressure ratio.
Okay, N1, EPR, and the third way.
The third way the AT defines its goal is simply through target airspeed. This is probably the most common mode once you're airborne. Usually, the pilot sets it directly using the speed knob on the mode control panel, the MCP. So in this mode, the AT is just commanding whatever thrust is needed to maintain, say, 250 knots, obviously up to the maximum N1 or EPR limit that the FMS has calculated for that phase of flight.
Right, so it won't exceed the engine limits just to chase the speed.
Exactly. The limits always take precedence. And the system's overall capability, using these three parameters, N1, EPR, or target speed, is pretty impressive. It can manage thrust or speed basically continuously, right from the start of the takeoff roll all the way through the flight, until it automatically disconnects after an auto land. Hashtag tag 1.2 system architecture and interface.
Okay, so to do that job across the entire flight, that AT computer must need a lot of information, right? A constant stream of data.
Oh, absolutely. This is where the real complexity comes in. And understanding this list of inputs is really vital for troubleshooting and, well, for answering those ATPL questions about what happens if something fails.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best